Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems and want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody, and welcome back to Math Wednesday. I hope you guys are all having a great week, a great day. I know a lot of people are on spring break right now, or your kids are on spring break right now. So before we get started, I always like to start with a little bit of introduction because I like to know who's here. It helps me guide our conversation throughout the night. The questions are set, but it helps me kind of guide what direction we take those questions. So in the comment box, if you could comment and let me know where you're from, what test you're prepping for, and are you a mountain kind of person or a beach kind of person? Like if you had to go one place for spring break or family vacation, would you choose the mountains or would you choose the beach? So where are you from? What test are you prepping for? And are you a mountain kind of person or are you a beach kind of person? We are definitely a mountain kind of family. We live in Orlando, Florida. We are an hour away from the beach and we are not beach people, that's for sure. We would much prefer to be on a lake or in the mountains skiing. So that's our preference. Like I said, I'm from Orlando, Florida. I'm a math coach and I just absolutely love spending my Wednesdays with you guys, going through a few problems and really kind of narrowing down a focus so that I can better help you prepare for your exam. Hi, Jada. How are you? Welcome. Tonight we are doing a geometry special. So many people always want help with geometry. That seems to be kind of a issue for a lot of people because there's just so much to geometry. There's so many formulas. There's so many applications. So I figured why not do a full geometry special tonight? So that's what we're doing. So let's go ahead and get started with the first problem. A teacher has her students practicing representing shapes on a geoboard using rubber bands. A child uses his rubber band to create a six-sided shape. What shape did the child create? Pentagon, hexagon, nonagon, or octagon? This question is definitely geared towards our pre-K through 3 test takers. I know we've got people from pre-K all the way through 12th grade. It's important that you know the names of shapes, but this kind of question is definitely geared towards our pre-K people. So we look at this and we see that a child is using their rubber band to create a 6-sided shape. As long as you know what a 6-sided shape is, you're good to go. You're going to be able to solve this problem, no issue. So let's just run through these shapes super quickly. We see pentagon. That prefix pent means 5. So this is a 5-sided shape. A hexagon, hex means 6. So this is our 6-sided shape, and this is going to be our answer. Nonagon is going to be a 9-sided shape, and octagon is going to be an 8-sided shape. A gon just means that it's a shape, like a polygon is a closed shape. So pentagon is 5, hexagon is 6, nonagon is 9, octagon is 8, and we know that our answer is going, oh, I circled C, but I meant B. So our answer is a hexagon, a 6-sided shape. It looks like we've got middle school, Praxis 5904, awesome. Mountain people, I love it. Canada, we actually went skiing up in Mount Tremblant up in Canada. It was a super fun trip. So, hi, Jada. All right, problem number 2. This is another pre-K through 3K through 6 problem. Don't worry, middle school and high school people, I've got you covered later on. Which of the following sets of shapes is similar? Now, I just said middle school and high school people, I've got you covered, but you've got to know what this word means. So, similar means that they are not congruent. They have the same proportions, but they are not congruent. So, congruent, knowing this vocabulary is critical for this geometry section, means they are equal. So, if 2 shapes are congruent, they have the same angles, the same size, sides, the same area, the same perimeter, all of it. If they are similar, they are proportional to each other. So that means that if I had like a square and then a square, and this side was 2, and this side was 8, then let's call these rectangles, not squares. And if this side was 3, then I know this side would be 12 because 2 times 4 is 8, 3 times 4 is 12. So they're proportional to each other. Another way I like to think of similar is like when we're looking at an image in like Microsoft Word or Microsoft PowerPoint or something like that. If I take that image and let's say it's a person, and I drag it from this spot right here to make it bigger, what's going to happen? It's going to stretch it out and make it look like the person is standing in a funhouse mirror. Same thing if we stretch it from the top. It's going to make them look like they're stretched all the way from that top piece, and it's going to make them look like they're like the Mr. Bendy guy. However, if I stretch it from the corner, it's not going to distort that shape any bit. And so if I made that shape bigger from the corner, those shapes would be similar. If I just copy and pasted this image, those shapes would be congruent. So in this case, A is not congruent or similar because we notice that these shapes are not even the same. We have a solid end on here, and then we have a pointed end. Letter B, these shapes are congruent. Letter C, these shapes are similar because they have the same proportions. One is just bigger than the other. And then D is also congruent. Congruent shapes can be turned differently as long as they have the same measurements. So D would be congruent. All right, problem number 3. Getting a little harder here. James has a box that he wants to paint. The box is a right triangular prism in which the right triangle has a hypotenuse of 15 inches and a base of 8 inches. The prism has a height of 20 inches. What is the surface area of the prism? So this is a tricky question because they didn't give us a picture to go off of. they gave us a bunch of words, and interpreting words is usually people's hardest thing to do. So he has a box. I know that. What shape is the box? The box is a right triangular prism. So we know the base is a right triangle of this prism. Remember, a prism has two bases and rectangles going around. So the difference between a prism and a pyramid, a prism is going to have two bases and then rectangles extending around that shape. A pyramid is going to have one base and then triangles extending up to a point. So in this case, we have a prism. We have two bases with rectangles around it. What kind of prism is it? A right triangle prism. So I know that I have two right triangles as my base. Those right triangles are identical. And then I've got rectangles that are surrounding this shape. So what do I know about this shape? It has the right triangle has a hypotenuse of 15. What is the hypotenuse? Vocabulary is critical when it comes to these geometry problems. If I have a right triangle, this is going to be my hypotenuse. It's always across from the 90-degree angle. This is a leg, and this is a leg as well. And the hypotenuse is always going to be across from that 90-degree angle. So if the hypotenuse is 15, let's go ahead and label that. And then it has a base of 8. The triangle has a base of 8, not the prism. That's critical. The triangle has a base of 8, not the prism. Then what does it tell us? So we did this. The prism has a height of 20. This is where people are going to label their picture incorrectly. I guarantee you that people would label this incorrectly. The prism has a height of 20. So many people would label this right here 20. Because what do we think of when we think of height? We think of how tall something is. And so if we call this the floor, that would be how tall the shape is in the normal world. However, the height of a prism, get this in your head, the height of a prism is the distance between the two bases. However, often the prism is drawn like this, where people assume this is the base because that's what it's sitting on. That is not the base. The base is the two identical shapes of the prism. So in this case, the right triangle is the base, and then the height is going to be here because that's what's connecting those two triangles. It could also be this one. It could also be that dotted line in the back. So looking at that, now I can label my height of 20. Now, I want us to think for a minute. What are they asking us for? They're asking us for the surface area. That's our next step. Obviously, this problem would not take this long if I was actually solving it on the test. I'm just walking us through every step. They're asking us for the surface area. K through 6, middle school, high school, GK, everybody needs to know how to find surface area and volume of basic shapes like these prisms and stuff. So we're looking for surface area. Surface area is the amount that I'm painting the shape. So really all I'm doing is trying to find the area of all the different pieces of this shape. You could look up surface area of a prism, surface area of a right triangle. You could look all those formulas up, but why hold that information in your head when you don't need to? Because I know the area of a rectangle. I know the area of a triangle, and all I'm going to do is add those all up. So let's take a look what we have. We have two triangles. So I'm going to find the area of two triangles. Then I have three rectangles, but they all have different dimensions. I have this purple rectangle. Then I have the blue rectangle, which is like that back side. And then I have this green rectangle, which is the bottom. So there's 3 different rectangles that we are looking at to find the area of. 1, 2, 3. Okay, I'm going to redraw our prism here so it's not so messy. So let's redraw this prism really super quickly. Oh, that was a terrible right triangle. Okay, 20, 8, and 15. All right, so the rectangles are going to be the easiest. I have 20 times 15. That's 1 rectangle. Then I have 20 times this missing side. I have not found that missing side yet, so I'm just going to write 20 times question mark. Then the green, I have 20 times 8. Are you seeing that? 20 times 8. What's the area formula for a triangle? Area formula for a triangle is 1/2 base times height. So I have my base, but I do not have my height of my triangle. Now, K through 6 people, they would give you the height of the triangle. You do not have to use Pythagorean theorem. I do not believe. Check your blueprint, but I do not believe that there is sorry, my phone's like buzzing because we have hail coming. And it was like, alert, alert, there's hail. You do not have to use the Pythagorean theorem. Everybody else, you need to know how to use the Pythagorean theorem. So we're going to use the Pythagorean theorem to find that missing side. A squared plus B squared equals C squared. So I have 8 squared, and we just disconnected. Lovely. It's not because of the weather. 8 squared plus X squared equals 15 squared. Why are we going to equal the 15 squared? We're going to equal the 15 because the 15 is the hypotenuse. So we want to make sure that we plug these numbers in the right place. When we're doing A squared plus B squared equals C squared, A and B are your legs, C is your hypotenuse. So 8 squared plus B squared equals 15 squared. I'm going to finish this up here. 64 plus B squared equals 225. Subtract 64 from both sides, and I get B squared equals 161, and I take the square root of that using my calculator because I'm not going to know that in my head. Again, if you need a calculator, they're going to give you one. This is not something any test would expect you to do in your head. B is going to equal 12.68. So what does that mean? That's the height of my triangle. So 12.68. So now I'm going to do area equals 1/2 base 8, height 12.68. So 1/2 of 8 is 4. 4 times 12.68. 4 times 12.68. 4 times 12.68. 50.72. That's the area of one triangle. But I have 2 triangles. So I'm going to multiply that times 2. And I get 101.44. Now I need to find the area of all my other rectangles. So I'm going to do 20 times 15. That's 300. I'm going to do 20 times 8. That's 160. And I'm going to do 20 times question mark, but it's not question mark anymore. It's 12.68. So 20 times 12.68 is 253.6. What am I going to do with all of that? I'm going to add all of those numbers up. So I'm going to add the 101.44. the 300, the 160, and the 253.6. So let's go ahead and use our calculator. 101.44 plus 300 plus 160 plus 253.6. And we get 815.6 0.04. Now, when we look at our answer choices, the answer choices have 815.12. We got 815.04. Could I resolve this problem? I could, absolutely. Here's what happened. They used an exact measurement for this, is my guess, and they didn't round it off. They didn't round the 253.6 off, and they didn't round the 101.44 off, which is why our decimals are just a little bit off. But I'm confident in the way that we solved it, so I'm not going to waste my testing time resolving this problem because I was 0.06 off or 0.08 off. If I was drastically off, I would have to resolve it. But in this case, I'm confident in the way we solved it, and we just rounded off, and the person who built this question did not. All right, let's keep going. I have 3 circle questions. These 3 circle questions are built out for 3 different levels of test. So these 3 circle questions are built out for 3 different levels of test. So we all need to know the coordinate plane. We all need to know how to plot a point on a graph. But then it's going to build after that. So let's take a look at and explore these circles. A circle is graphed on an XY coordinate plane. What is the coordinate of the center of the circle? Now, if you looked at the GK or like the K through 6 blueprint, you may not see circles defined on those blueprints. Praxis definitely has circles defined, but you will see coordinate planes defined. So just because they didn't define circles doesn't mean you don't need to know how to find a coordinate point. In this circle, we have a circle, and we have the center of the circle. All they asked us for was the coordinate point. So, quick review of coordinate plane. This is your first quadrant. This is your second. This is your third. And this is your fourth quadrant. We go counterclockwise from the top right. Here's your origin. And your origin is just where your coordinate plane starts when you're counting right, left, up, or down. This is your x-axis. This is your y-axis. And when we go to the right, it's positive. When we go to the left, it's negative. When we go up, it's positive. When we go down, it's negative. So in this case, when we're looking for this point, we're going to have a negative answer because we're going negative to the left and we're going negative down to get to that point. So when I look at my answers, there's only one answer that's a negative, which is B. So already I know the answer is B and I haven't even solved it. Now, they're all 4s and 3s, so it's pretty obvious why that's the answer. I counted -4, 1, 2, 3, 4, and I counted -3 down. But knowing which direction we're going on a coordinate plane is important. You're always going to start with your X and then do your Y. So I'm going to go right or left first, and then I'm going to go up or down. I have to get on the elevator before my elevator can go up or down. So I have to walk onto the elevator, and then my elevator can go up or down. So in this case, our answer is B. A lot of questions will ask like, which of the graphs has a coordinate in the second quadrant? Or pick the point that's in the third quadrant, and you have to be able to identify which point is in that quadrant. Those are some very basic coordinate plane questions that you might see. But let's make this a little harder. The same circle is graphed on an XY coordinate plane. What is the equation of the circle? So, equation of a circle is x minus h squared plus y minus k squared equals r squared, where h comma k is your center and r is your radius. What is the radius? The radius is the distance from the center to the outside of the circle. So this is a radius, this is a radius, this is a radius, this is a radius. Any of those would be radii. What is a diameter? A diameter is the distance from one point of a circle to another that goes through the center. So that's a diameter. That's a diameter. That is not a diameter. Even though it goes from one point of the circle to another, it doesn't go through the center, so it's not a diameter. So that's just a little extra information. So when we look at our equation, you notice that the original equation is minus, but the center is positive. So let's identify our center here. Our center is 1, 2, 3, -4. 1, 2, -3. So the center is -4, -3. We already figured that out in the last problem. When I plug it into the original equation, I have x minus -4 plus y minus -3 equals r squared. We'll get to the r squared in a minute. What is a negative times a negative? A positive. So because we have two negatives sitting next to each other, they become a positive. So this actually becomes x plus 4 squared plus y plus 3 squared equals r squared. Now, what is my r? Let's go back to my circle. My radius, as we said, is the distance from the center to the outside. So we have 1, 2, 3, 4, 5. So my radius is 5. But don't get tripped up that this is 5. That is r squared. So this is going to be 5 squared, which equals 25. So our answer is going to be A. But let's take it one step further. The same circle is graphed on an XY coordinate plane. A square is inscribed inside the circle. What is the area of the square? All right, so we went from basic coordinate plane to equations of the circle to a square being inscribed inside the circle. What does that even mean? What does inscribed mean? And I'm going to caution you right now, we just got a huge hailstorm. So if the internet cuts out and I lose my feed, I apologize in advance. I'm hoping that doesn't happen, but I just wanted to give you a heads up. What does inscribed mean? Inscribed means it's inside the shape as tight as it can possibly be. The vertices are sitting on that circle. So the vertices are sitting on the circle. Do not assume that this is a rectangle because it looks like a rectangle, or it's a square because it looks like a square. We have to use information that they gave us. They told us this is a square, even though my eyes are saying it kind of doesn't look like a square. They told us it's a square, so we're just going to assume that. What is the area of the square? Well, what information do I need to know to be able to find area of the square? Area of a square equals length times width, or length squared, really. So I need to know what the measurement of one of these sides is. But how am I going to solve that? Well, what do we know? Let's start there. We know that we have a radius and another radius and another radius and another radius. And what are those radii measure at? 5. We already counted that, but we can count them again. 1, 2, 3, 4, 5. So our radius is 5. So that means that this is 5, this is 5, this is 5, and this is 5. What else do we know? We know that the diagonals of a square intersect at a 90-degree angle. So this is a 90-degree angle, so is this, so is this, so is this. So there's two ways I can solve this. I can find the area of this triangle by doing 1/2 base times height. And then I can multiply by 4. Let's do that. Area of a triangle, that's a highlighter. Area of a triangle equals 1/2 base times height. 1/2 times 5 times 5. Well, what is 5 times 5? 25. So it's 25 divided by 2. So then this is 25 divided by 2, and this is 25 divided by 2, and this is 25 divided by 2, and so is this, because they're all the same. So I can do 25 divided by 2 times 4, and when I multiply fractions, I can just multiply the tops and the bottoms. So 25 times 4 is 100, divided by 2 is 50. That's how I would solve it if I was K through 6, GK, didn't need to know the Pythagorean theorem. But if I know the Pythagorean theorem, I could also solve it by using the Pythagorean theorem. So we already established that we know that this is 5 and this is 5 and this is a 90-degree angle. So I could find the missing side of my triangle by doing a squared plus b squared equals c squared, and that would give me the side of my square that I'm looking for. So a squared plus b squared equals c squared. 25 plus 25 equals c squared. 50 equals c squared. Take the square root, and I'm just going to leave it as the square root of 50. So the side is the square root of 50. Now I can do area of a square. Area of a square is length times width. Well, square root of 50 times the square root of 50 is going to be 50, because when I multiply two square roots together, I end up just getting that as the number. Like, think about this. If I do the square root of 3 times the square root of 3, I get the square root of 9. And what's the square root of 9? 3, because 3 times 3 is 9. So if I have two square roots that are the same, I don't need to waste time chunking that into my calculator. I just know that two square roots that are the same are going to give me the answer that's under that square root. So all that said, two very different ways to solve it, one more complex than the other, but neither way is the right or the wrong way. It just means that we've solved the problem differently. All right, problem number 8. A landowner is building a fence on her property behind her house. The fence will enclose her square yard that has an area of 1,600 feet squared. If her house has a length of 29 feet, how much fencing will she need? This is a very interesting problem because some people are just going to jump right to it and they're going to get the wrong answer. What do we know? We know that she has land, she has a house, and her yard is 1,600 square feet, and it's a square. So let's draw her house. Here's her house. I always draw a picture when it comes to geometry. And then she has a square yard. But what we don't know is if the yard goes like this, or if the yard goes like this and creates a square. We don't know that yet. But what we do know is that the yard has an area of 1,600 square feet. So we know that this grass is going to equal 1,600 feet squared. So what can I do with that information? Well, I can square root that number because I know that area equals length times width. But really, in a square, they're going to be the same. The length and the width are going to be equal to each other. So really my area is 1600 equals length times length, which is just length squared. And I can square root both sides. The square root of 1600 is 40. So one side of my square is going to equal 40. So what does that mean? That definitely means that the yard does not do this. Why? Why does that mean the yard does not do that? Because we were given the dimension of the house. The house is 29 feet long. So this right here is 29. Why is that significant? Because I'm not going to put a fence up against my house. I'm not going to pay for fencing to sit up against my house. But what that tells us is that this is not the answer. The fence is going to have to extend out from her house and then go up and around. So if I know that this side is 40, this side is 40, I also know that this side is 40. And I know that this side needs to equal 40, but I already have 29 feet that I'm not using. So if I do 40 minus 29, I get 11. What does that 11 mean? That means that this much and this much has to equal 11. So I don't need to figure out that this is 5.5 and 5.5 because 5.5 plus 5.5 is 11. I don't need to know that because it doesn't matter, because the house plus 11 feet of fencing, no matter how you slice it, is going to give us that missing side of the square. So how much fencing do I need? I need 40 plus 40 plus 40 plus 11, because this is the missing piece of that missing side. So 40 plus 40 plus 40 is 120, and 120 plus 11 is 131. So our answer is B. All right. Shown below are statements describing the properties of quadrilaterals. Which of the following statements are always true? That is our key word, always. We're looking for statements that are not sometimes true, that are always true. Everybody in this room needs to know the properties of quadrilaterals, because you're either going to have to identify something like this with properties of quadrilaterals, or you're going to have to apply your knowledge of quadrilaterals to solve something like this, where we're using diagonals to solve it. We didn't have to use diagonals. Well, we actually did have to use diagonals, so you need to know that. So let's go ahead and look back at our properties. Every quadrilateral is a rectangle. When I'm looking for always true statements, all I'm trying to do is think of one example that is not, and then I can cross that one off. So every quadrilateral is a rectangle. Is that a rectangle? No, that's a trapezoid, and a trapezoid is definitely not a rectangle. So this is not always true. Is it sometimes true? Are some quadrilaterals rectangles? Yeah, absolutely. That would be a sometimes true statement, but it's not always true, and that's what we're looking for. So one is out. Number two, every square is a rectangle. So no matter what the square looks like, is it a rectangle? Well, let's think of the definition of a rectangle. A rectangle has to have 90-degree angles, and it has to have two pairs of congruent parallel sides, which just means that this side has to be equal to this side and parallel, and this side has to be equal to this side. Well, is that true for a square? Yeah, every square has that. Now, all 4 sides are the same, but are these 2 sides the same? Yes. Are these 2 sides the same? Yes. All 4 of them are the same, but that doesn't matter. Every square is a rectangle. Yes, absolutely. Every parallelogram is a square. Already, I know that that's not true because I can draw a parallelogram that looks like this, and that is definitely not a square. Every rectangle with 4 congruent sides. So I'm going to draw a rectangle that has 4 congruent sides is a square. This one's hard to think about. Every rectangle that has 4 congruent sides is a square. Yes, that is true. How do I know that? Because if it's a rectangle, it has the 90-degree angles that a square needs to have. Let's take this. Every quadrilateral with 4 equal sides is a square. What do you think about that one? Is that always true or no? Every quadrilateral with 4 equal sides is a square. What do you think about that one? That is not always true. Why? You're like, why? It has 4 equal sides. Why is it not always true? Well, what about this? What is that? That's a rhombus. And a rhombus can sometimes be a square, but these are not 90-degree angles. They're 4 equal sides, but it's not 90-degree angles. So this would not be true either, but I kind of side tangent on that. Every square is a rhombus. Yeah, that's true. Why? Because the definition of a rhombus is literally just 4 equal sides. It's a parallelogram with 4 equal sides. So every square is going to be a rhombus because every square has 4 equal sides. Every quadrilateral with congruent opposite angles is a parallelogram. Whew, that's a lot of vocabulary in one sentence. Every quadrilateral with congruent, equal, opposite angles. So if I look at a parallelogram, like a true, like classic parallelogram, and I look at congruent opposite angles, those are equal. Those are opposite from each other. They are not adjacent. These are adjacent. These are opposite. And if they're congruent, they are a parallelogram. So that's going to be true too. So I'm looking at 2, 4, 5, and 6. However, a little strategy for this kind of problem, if you're not sure on some of them, use your answer choices to help you. So let's say you're super confident that number 4 is always true. Let's say that's the one that you're like, yes, absolutely. If there's an answer choice that does not have the number 4 in it, you know it's wrong. So A has 4, B has 4, C has 4, but D does not. So no matter what else D has, you know D is wrong. Let's look at another one. Let's look at another one that you're super confident with. Every square is a rhombus. Let's say you're like, I know every square is a rhombus. So you know that you need number 5 in your answer choices. Well, now A doesn't have number 5. So I'm left with B and C, and I can make an educated guess if I'm not confident with the other statements. So use those answer choices to help you. All right, let's move on to the next problem. This is the last geometry problem that we have, but I do have 3 problems from last week that I brought that we were not able to solve last week because I didn't have the right answer choices. So we're going to solve them today, and they are for my high school people. However, Dr. A does have a special code for everybody at the end of this when I'm done solving those problems. All right. The heights of a rectangle and trapezoid are congruent. However, only one of the bases are congruent, where the other base of the trapezoid is 8 more than 3 times the base of the rectangle. What is the area of the trapezoid? We're merging geometry and algebra here because we've got an algebraic statement right here that we have to interpret. So let's go ahead and look at this. I've got a rectangle and a trapezoid. I'm not even going to read the problem again until I draw a rectangle and a trapezoid. What do I know about a rectangle? We have length times width or height times base, which is what I'm actually going to use because those are the variables that are being used in the answer and the vocabulary that's being used in the problem. So height times base, length times width. And then I have height here, and I have base 1 and base 2. And I know that the area of a rectangle is length times width or height times base. And I know that the area of a trapezoid is 1/2 base 1 plus base 2 divided or times height, or base 1 plus base 2 divided by 2 times height. Now, what did they tell us? They told us that the heights are congruent. So H equals H. What else did they tell us? They told us one of the bases is congruent. So let's call this equal to this. So base and base are equal. But then it says the other base of the trapezoid is 8 more than 3 times the base of the rectangle. So what I know is that this right here, I'm going to change colors. This right here, base 2, is equals 8 more than 8 plus something or something plus 8. Don't even get me started on that. That's another conversation for another day. But something plus 8. 8 more than. 3 times the base of the rectangle. 3 times the base of the rectangle, which is also base 1. So I have 3b plus 8 equals base 2. So I can replace base 2 with this. So I have area equals base plus 3 times base plus 8 divided by 2 times H. Why did I just do all of that? Because I'm trying to find the formula in terms of 1 base and 1 H. Let's keep going. 3b plus 1b is 4b. So area equals 4b plus 8 divided by 2 times H. Now I can divide all of these by 2. If this was like 4b plus 7 divided by 2, I would not be able to divide the 4 and the 2 unless I also divided the 7. So I have to divide everything by 2 because it's an addition sentence. So this ends up being 2b plus 4 times H, which is D. I'll make sure I go over why I did something plus 8 instead of 8 plus something next week. I'll make sure I go over that next week. All right, geometry is done. I want to make sure I hit on at least one of these problems tonight before we run out of time. Last week we had this problem. However, I did not have the correct answer choices. So today I do. All right, An object is traveling through space with a velocity of v of t equals 5t plus 4. What is the particle's position at t equals 2 seconds? This is for my 6 through 12, 7 through 12 people. This is definitely a calculus problem. So, what do we know about velocity, position, and acceleration? Like I said, don't leave yet, even if you're not needing this, because Dr. A has a special code for everybody. I know that position is the original function. I know if I take the derivative of the position function, I get velocity. And if I take the second derivative of the position function, I get acceleration. So they've asked us for the position, which means we're looking for the, oh, that was not a good color. We're looking for the original function, which means we have to find the integral, not the derivative. If you're finding the derivative, you're going down my list. If you're finding the integral, you're going up the list. So in this case, I have to find the integral of v of t equals 5t plus 4 to find my position function. Now, what do I know about finding the integral? I'm going to use like the opposite of my power rule when I'm finding the derivative. So I know that if I used the power rule to find the derivative going this way, that what ended up happening is I would have a 4t because I would have a 1 here. I would drop that 1. 1 times 4 is 4. Subtract 1 from that exponent, and it would be 0, which gives me the constant of 4. I'm going to use that same philosophy to find the integral of 5t. What ends up happening is if this is a 1, I'm going to add 1 instead of subtract 1 if I'm finding the integral. So t squared, but what is this number going to be? Well, it needs to equal 2 times something, because when I find the derivative, I'm going to multiply the 2 times that constant, and it needs to equal 5. So 2 times something has to equal 5. Divide both sides by 2, I get 5 halves. That's messy and people shy away from it. That's okay that it's messy. So I have P of t equals 5 halves t squared plus 4t. Now, all they asked us for is the position at 2 seconds. So I'm going to find P of 2. I'm going to plug 2 into t equals 5 halves times 2 squared plus 4 times 2. So 5 halves times 4 plus 8. Those cancel out. 5 times 2 is 10. 10 plus 8 is 18. So C is our answer. Excellent job. That, again, is for my high school people only. All right, let's do one more. We have time for one more. The position of a particle can be defined as x of t equals 0.25 t cubed plus 4t. Find the instantaneous velocity of the particle at 3 seconds. Don't get confused by their ability to use big words here. Instantaneous velocity just means find the velocity at 3 seconds. It's just at that instant. That's all they want. Well, if this is the position, what do we have to find? We have to find the derivative of that function. So if x of t equals 0.25 t cubed plus 4t, then x prime of t, I'm going to take this, use my power rule, drop the 3. 3 times 0.25 is 0.75. Subtract 1 plus 4, because I dropped the 1, subtracted 1, and I got 0. Now I'm just going to find the instantaneous velocity at 3. So 0.75 times 9 plus 4. 0.75 times 9 is 6.75 plus 4, not times 4, and we get 10.75. Excellent job. Those are always super fun. I don't know why, I just love it. All right. Thank you guys so much for hanging out with me on Wednesday Math Night. I hope to see you next week. Don't leave. I'm going to turn it back over to Dr. A so he can give you a special code so that you can sign up for any of our boot camps to help you keep practicing these math problems. And I hope to see you all here next week on Facebook or YouTube. And with that, I'm going to turn it back over to Dr. A. Thanks, y'all.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.